Hello students, welcome to Concept Clarity for Physics and Maths. Today we are going to talk about geometric progressions. Last time we have covered arithmetic progression and we have also seen the common summation for n natural numbers, n even numbers, and you can do one more for n odd numbers as well. You can do it as homework. Geometric. So we are going to see geometric progression. So what is geometric progression? Geometric progression, what is it, sir? Tell me fast. Geometric progression, student, is a sequence. Sequence again. Sequence again. Sir, you said arithmetic progression also is a sequence. Yes. Geometric progression also is a sequence. Wait here. Please continue to hear. Sequence of numbers. So arithmetic progression also was a sequence of numbers. Yes, it was a sequence of numbers. There it was successive number different. Here it is such that what is the key difference? There it is, the difference. Here it is such that the ratio. Oh, ratio. Yeah, very important. Geometric is basically ratio of any term and the term just before it. Sir, why so complicated explanation? So basically, it's the successive term only. Yes, it's a successive term. Basically, the successive term. What about the successive term? The ratio of the term and the term just before it. The ratio must be a constant. Here also constant. Yes, but here the ratio should be constant. And this is called as the common ratio. There it was called as the common difference. Here it is common ratio. Let us see an example. Here itself we'll see an example. Shall we? So you have a sequence like 1, 2, 4, 8, 10, okay, and so on. So now you have, let us pick this 2, right? So 2 divided by 1, 2 divided by 1 is 2. 4 divided by 4 divided by 2 is also 2. 8 divided by 4 is also 2. So the ratio of successive terms has to be a constant, and that constant is called as the common ratio, right? So let us see some of the expressions for geometric progression, some of the formulas for geometric progression. I'll wipe out this so that we can move on to the formulas. So let us say we have a geometric progression which is A1, A2, A3 all the way till AN. So the ratio will be R is the ratio which will be A2 by A1. Similarly, all the way you will go and you will have the final AN divided by AN minus 1. This is going to be the common ratio. So now the formulas. So why are you doing? Just catching up with my words. Okay. Nth term of geometric progression is nth term of a geometric progression is given by first term multiplied by ratio raised to power of n minus 1. This is the formula for nth term of a geometric progression. So geometric progression can be expressed as, it can be expressed as a, then this is AR, and can be expressed as AR ka square, then AR cube all the way. Okay. Then sum. First n terms. What is the sum of first n terms? It is given by sum of first n term is equal to a 1 minus the common ratio raised to the power of n divided by 1 minus r. This is for any value of r. Okay. Any value of r. Now let us take specific cases. If you have noted down this, these are the two formulas. One is for the nth term and is one for the sum of the first n term. Okay, I'll wipe out this. Now let us consider geometric progression of infinite terms. We have 1, 1 by 2, right? 1 by 4, 1 by 8, all the way till infinity. Here the common ratio will be what? What is the common ratio? What is common ratio? This divided by this, right? This divided by this. So you'll have 1 by 4 divided by 1 by 2. So what will you get? You'll get 1 by 2, right? 1 by 2 is less than 1. So the common ratio is basically less than 1 for this particular geometric progression. So when in such a case where the ratio is less than 1, then you can say sum of infinite numbers is equal to a divided by 1 minus r, where r is less than 1 but greater than minus 1. Okay, r is less than 1 but greater than minus 1. Okay. So this was the infinite series specific case which we have seen. If I missed out anything, please write in the comment section and I'll cover it in the subsequent video. Thank you. Until then.